Hi, hello everyone. Good evening to all of you. Welcome to ACE Preparation League 2. So, today we are going to have a discussion on how to prepare operating system subject for GATE examination. Of course, this particular session can be helpful to you even how to prepare operating system subject for the interview perspective also. So, as part of that, let me introduce myself. This is Venkateswarlu, faculty of ACE Engineering Academy, Computer Science Department. So today, what is the agenda of this particular session? First, let us have a look into that, and then we can start our actual concepts. Okay, right. So this is the agenda of today's session. So in this agenda, first we are going to see operating system syllabus with respect to GATE examination. After that, we can see operating system weightage by considering some analysis of the previous year GATE papers such as GATE 2022, 21 and 20. So we can do some analysis on those papers and we can simplify or else we can come to the conclusion on what is the weightage of this particular this particular operating system subject. Okay, and then we can see after knowing about the syllabus of this operating system, among them, what are the more focused concepts? That thing also we can have a look in this session, and at the end we can give the summary on this entire session. Okay, so first let us look into syllabus of this particular operating system subject with respect to GATE examination. So syllabus of operating system subject is very simple. If you can think, there are only four topics. As part of this operating system, you are having only four topics. Like you have introduction to operating system, that is the first one, and some basic background also we can see. After that, process management. After that, memory management, and then file system. So very simplified syllabus it is. If you look into actual syllabus which is given by IIT, which is organizing GATE examination, that you can start, you can see that the syllabus have started with system calls and then processes and then threads and then inter-process communication, deadlocks and concurrency. Instead of that, I just simplifying the entire syllabus of operating system subject just in four topics. So this is what your syllabus of operating system with respect to GATE examination. But what are the subtopics of each and every main topic here? So I just showcase here only main topics. But what are the subtopics that we can have? Those subtopics we can see one by one. Okay. But before that, let's have the analysis, or else you can say that let's have the idea of what is the average marks, or else what is the weightage of this particular operating system subject with respect to GATE examination, that we are going to see now. By considering, as I clearly stated, that we are going to consider the last 3 years GATE papers such as GATE 2022, GATE 2021 and GATE 2020. So look at first, if you consider GATE 2022 paper analysis, from this operating system you have 10% of marks. So what does it mean? If as you know that your GATE paper is worth of 100 marks, among the 100 marks from operating systems, according to GATE 2022 examination question paper, you can observe that there are 10 marks from this particular operating system. At most 10 marks you can say from this operating system. And the same, if you verify GATE 2021, you know that GATE 2021 is been having two sessions of computer science and information technology papers were there. There are 2 sessions they have conducted. In one session, if you look into the set 1 is one session, morning session you can consider. In that morning session question paper of GATE 2021, you can see from operating system again 10 marks. Means if your paper is 100 marks worthy, and among that 100 marks, 10 marks we had from this particular operating system subject. And then if you verify the second paper, I mean second shift, which is conducted in afternoon session, from that particular second shift paper or else paper 2, set 2 paper, from operating system you have 7 marks. Out of 100 marks, 7 marks you are having from operating system. And then if you verify GATE 2020 paper, again from this operating system subject, out of 100 marks you have 10 marks here. So what is the idea you are getting now? What is the weightage you can expect, or else how many number of marks we can expect at max from this particular operating system subject with respect to GATE examination? So by looking at all these 4 papers analysis, we can make a conclusion that, so if you verify here, from 2020 we have 10 marks, from 2021 set number 2 you have 7 marks, from 2021 set number 1 you have 10 marks, from 2022 from operating system you have 10 marks. So overall if you verify these pie charts or else analysis of these last year 3 papers, if you verify from operating system subject, you are having at max 10 marks. So weightage of this particular operating system subject. So it is worth of, operating system is worth of 10 marks. It is worth of 10 marks. And maximum is 10 marks. This is maximum I am saying. This is maximum I am saying. And minimum you can expect 7 marks. So minimum 7 marks we can expect, and maximum 10 marks we can expect from this particular operating system subject. This is the weightage of operating system subject with respect to GATE examination. Okay. So I hope you got an idea what is the weightage of this particular operating system subject with respect to GATE examination. And then we are moving to the next one. Syllabus, we have stated that there are 4 main contents like introduction and background, process management, memory management, and file systems. So like that we just stated 4 main topics of operating system, right? So those 4 topics we are going to see, all the subtopics of those 4 topics we are going to see. Okay, right. So verify first, if you consider first chapter or else first topic, main topic of operating system syllabus, if you verify, that is introduction and background. So here, as part of this introduction and background, we are looking at various definitions of operating system. So we cannot define operating system in a particular way. There are so many definitions for operating system. So that's why we have mentioned that various definitions we can see. Like for instance, I can say operating system is an interface between the computer hardware and computer user. That is the most popular definition we can see. And after that we can also see the next topmost definition for operating system is a resource manager or else resource allocator. And the next definition we can see, operating system is a control program which can manage the computer hardware. So like this there are several definitions we are having for this operating system to define. But is there any definition is correct definition for operating system in the sense? No. That is depends on the environment, usage, how you are using the system. Depends on that you can define what exactly the operating system is. Right? So after looking at the definitions, then we can see what are the various goals of an operating system. So if you consider the goals, all operating systems are having the same goal in the sense? No. So the goals are vary from operating system to another operating system. So if you consider, for instance, if you consider Windows operating system, the main goal of Windows operating system is convenience. But when it comes to real-time operating systems, if you consider, the more real-time operating systems, if you consider, the main goal of that real-time operating systems is efficiency. But if you consider mobile operating systems, if you consider Android operating system, it is both like convenient as well as efficiency. So it means that goals of operating system, every operating system can have a primary goal and secondary goal. But mainly if you verify our current modern operating systems, if you verify mainly we are working with Windows and Unix, right? But most of the people are comfortable with Windows. So that's why the primary goal of operating system is convenience, which is easy to use, and the secondary goal of an operating system is, you can say that efficient or else efficiency. After that, we are having ability to evolve, which is called scalability. Along with that, you can also have robustness, and you can also have portability. So like this, there are so many goals for operating system, but those goals are vary from one operating system to another operating system. So this type of theory is very important with respect to goals of an operating system here. And then if you look into location of OS, so here location of OS, I can say that the location of OS, I can say that it is, you can say that this is dual mode of operation. So here you must study about dual mode of operation, dual mode of operation. So what is the dual mode of operation? So the dual mode of operation in the sense, operating system is allowing the CPU to execute both kernel instructions as well as user instructions. It means that user mode and kernel mode. So we are having dual mode in the sense we are speaking about two modes here. One is kernel mode, another one is user mode, right? So initially where we are in the user mode. So later when we are coming into kernel mode, and which instruction is allowing you to move from user mode to kernel mode, and after performing kernel mode of operation executions, then again from kernel mode to user mode, how we are coming back, which instruction is doing, which instruction is allowing you to move from kernel mode to user mode. See, this entire theory is very, very important. We need to concentrate on that particular concept. So from this introduction and background, which is the first topic of operating system syllabus, you need to very much concentrate on this particular topic, location of OS, which is dual mode of operation. We have several previous year gate questions also based on this particular dual mode of operation. So we need to careful about this dual mode of operation, right? After that, you can see history, like in first generation, what type of operating system is being used, in the second generation, what type of operating system is used. So such things we can discuss as part of this history. And then we have various types of operating systems. So types of operating systems are starting with batch systems. You know that there are several operating system types, like for instance, I can write some of them like batch systems, and then multi-programmed systems. You know this, multi-programmed systems and multitasking systems, right? So multi-programmed systems, multitasking systems, multitasking systems, right? And we are having multi-programmed, multitasking, batch operating systems, after that real-time systems, after that we are having multi-processor systems, So like this, there are several types of systems we are having, operating systems we are having. So multi-processor systems, so such as we are having so many operating systems in real world. But with respect to GATE examination, if you think these are the main topics, main types of operating systems, you can also see distributed systems, you can also see network operating systems. So these are all additional types of operating systems. They are all not much important with respect to GATE as well as interview perspective. But with respect to interview perspective, it is very, very important to understand what is this batch systems, what is this multi-programmed systems and multitasking systems. These things we should be well known. And even in the GATE examination also, from batch systems, we have around 2 to 3 times of previous year GATE question based on a term called spooling. I hope you are all aware of this particular word, like spooling, simultaneous peripheral operations online. So this particular, based on this particular spooling concept, you have around 2 to 3 times of previous year GATE questions, which is given in 1992, 94 and 96. After that, multi-programmed systems. So this is one important topic I can say among these various types of operating systems. And from this multi-programmed systems also, we have one previous year GATE question. And from multitasking systems also, we have one previous year gate question. So like this, from this particular introduction and background might be a theory concept. It is might be a theory concept. It is might be a theory concept. But from this particular theory, okay, so we are having questions. Already we had questions from the previous papers like dual mode of operations. We have questions, and based on types of operating systems also we have questions. So overall, from this particular introduction and background to the operating system, I can say these are the two topics which we must be focus, right? We must be focus on these two topics. What are the two topics? One is dual mode of operation and another one is various types of operating systems. And this particular introduction and background main topic of operating system is worth of 1 mark. It is worth of 1 mark. We can expect at max 1 mark questions only here. And even we can also, there is a scope to get the questions, a kind of questions called MSQs. So MSQs are possible from this particular introduction and background of operating system, that is mainly based on the location as well as types of operating systems, right? Along with the MSQs, we can also have MCQs also. Both type of questions we can expect from this particular introduction and background of operating system. Okay, so after this main topic, then we are moving to the second topic, that is your process management. Look at this process management. See, there are so much of information, so much of theory as part of this process management. So if we cover this entire theory and numericals in the same heading of process management, might be we people can feel bit difficulty while we are doing the revision. Then it's better to fragment or else to segment that into 3 parts, like process management part 1, process management part 2, and process management part 3. Then it would be easy to you to understand the entire theory of this particular process management as well as the numerical part also. So as per my convenience, I am suggesting you that this process management you can visualize into 3 parts like this. Don't consider the entire theory of process management under a single umbrella, that is process management. Don't consider like that. You just please divide that entire topic, entire theory of this process management into 3 topics like this. So then in the first topic, what are the subtopics we are going to see? So the subtopics we can see as part of this process management part 1 is process and its concept. So here we can define what do you mean by a process and program, process versus program. What exactly the meaning of process and what exactly the process versus what exactly the difference between process and program. So there is a scope of interview point of question, there is a scope of gate question from this particular process and its concept, that is also theory mark. This is also theory based questions which are worth of 1 mark. This is one of the most frequently asked question in the interview perspective, what exactly the difference between process and program. So this must be focused. I mean this particular topic also must be focused here. Then image of a process. So after loading your program into the main memory, then you are treating it as a process. Then how that main memory, how that allocated main memory can be used by this particular process, or else how we can visualize the allocated memory, main memory that is being allocated to this particular process. Okay, whatever the main memory portion that is allocated to this particular program or its process, how we can visualize? Like we can visualize that particular allocated memory into 4 parts. Like heap section, stack section, text section, data section. So what exactly the text section contains, what exactly the data section contains, and what exactly the heap section contains and stack section contains. These things must be well known to us, right? So after that, the next topic is process state diagram. So this is the most important from this particular process management part 1. I can give a single tick to this, but for this I am giving you double tick, means it is most important than the remaining 2 subtopics of this particular process management part 1. So here in this process state diagram, see the process state diagram can be visualized into 3 diagrams. Like a process can have 2 states, then it can treat as 2-state diagram. A process can be visualized into 5 states, then it becomes 5-state diagram. A process can be visualized, a lifestyle of the process can be visualized into 7 states, then it is called 7-state diagram. So like this we are having process state diagrams, 3 state diagrams we have, like 2, 5 and 7. So from this particular 5-state diagram, we have 2 times or 3 times of previous year gate questions. So the entire theory, so from which state to which state a process is been moving after a particular operation, when a process is moving this particular state, when a process is moving from this particular state to this particular state, how many number of process can be part of in this state. These type of theory points must be well known, as well as the action, which transition is valid, which transition is invalid. If a process is moving, a process can move from ready state to the running state, is a valid transition from ready state to the running state. A process can move from running state to the exit state, is not a valid. So such theory is very, very important. So you need to focus on the transitions. When a process can be in this state, what is the meaning of, if a process is in particular state, let's say a process is in ready state, what does it mean? It means a process is ready for execution. It is ready for execution. Its creation is being done. The process is successfully created and it is ready for execution. Then we can say that the process is part of ready state. When a process is part of IO state, then what it is mean waiting state. What does it mean? It is waiting for an IO device to perform some IO operations. So like that, so when a process is part of so and so state, what is the meaning of that particular state? And when a process can move from this state to this state, let's say a process is moving from waiting state to ready state. When its IO operation is being completed, then a process can move from waiting state to ready state. And there are some abnormal transitions also, which are, you can say that undesirable transitions also, like a process can move from running state to suspended ready state. And it is called undesirable transition. When a process can move from running state to the suspended ready state. When a process is, when operating system have stopped, or else when there is something went wrong with the system program, like such as if you consider some process scheduler. Process scheduler is a system program. If that system program is not working well, suddenly while a process is in running state, there is a crash in that particular system program called process scheduler system program. Then what will happen? The process execution cannot be done. Like if compiler is being cracked, if particular linker is being cracked. So if something is happened like this, then a process can move from running state to suspended ready state. So such type of undesirable transitions also can be happened, but when a process can move from one state to another state, what is the meaning of? A process is in particular X state, what is the meaning of that? Which is valid transition, which is invalid transition? These things must be well known. So when you get the concept, when you get the confidence on that particular theory is when you have seen very carefully about this all 2-state diagrams and 5-state diagram and 7-state diagram, and when you are having a big concentration on this each and every state of a process, then only you can be able to answer the questions based on this 2-state diagram and 5-state diagram and 7-state diagram. You may expect questions from this particular process state diagram. MCQs are possible as well as MSQs also possible based on this process state diagram. Right? How many number of processes can be part of running state? How many number of processes can be part of ready state? How many number of processes can be part of running state, waiting state? So such type of questions also possible to ask from this process state diagram. And there might be uniprocessor system and there might be multiprocessor system. Let's say there is one previous year gate question, how smart the question is. Like there is a system in which we are having n number of processes, n number of CPUs we are having. n number of CPUs we are having. Then the number of processes that are part of the ready queue of that particular CPU is. So this is one previous year gate question. It is mentioned that like n square, 2n and independent of n. What is the exact answer for that question? If you verify, it is independent of n. How you can say that? Because see, the thing is how we can say that in the sense, let's say if we consider the ready queue, let's say if you consider my stomach is a ready queue for me and if our stomach is ready queue for you, and as I am looking as fat, might be I am able to eat 8 idlis. As you are looking like thin, might be you are able to eat only 3 idlis. It means that your ready queue length is 3 and my ready queue length is 8. And being a CPU, I am a CPU and you are CPU. We both are having independent length, ready queue length, so independent of n. So some smartness is required to answer such type of questions. That smartness when you can achieve in the sense when you concentrate in the classes, when you are well known about the theory concepts of this process state diagram and etc. After this process management part 1, so from this process management part 1, I am emphasizing the question, emphasizing on process state diagram, better to have a better preparation on this particular topic. There is a possibility for having a question from this process state diagram exclusively from this particular main process management part 1. After this process management part 1, we are having the next topic which is process management part 2. So here we are having process scheduling. So in this scheduling we can cover or else we have to learn about what are the various types of schedulers we are having. Schedulers. So what are the various types of schedulers we are having? You know that we are having schedulers called medium term scheduler, long term scheduler, short term scheduler. So like this there are three types of scheduler programs we have. So what exactly the medium term scheduler is doing, what exactly short term scheduler is doing, what exactly the long term scheduler is doing, where this in which state between which states long term scheduler is being residing, between which states the medium term scheduler is residing, between which states the short term scheduler is residing. So these things are well known. These things should be well known, right? So after these schedulers, we can also see into various scheduling queues. We are having some scheduling queues like ready queue, device queue, job queue. So where the job queue is, where that ready queue is, in which state the job queue is existed, in which state the ready queue is existed, in which state the device queue is existed. So these things must be well known here. So that is what the main thing here. And after that, various types of process schedulings. So what are the various types of schedulings we have? Like preemptive scheduling, non-preemptive scheduling. So what do you mean by preemptive scheduling and what do you mean by non-preemptive scheduling? So these things must be well known. So these are the topics which you have to more emphasize on the, as part of this process scheduling. Along with this, there are some important definitions we have. Like the important definitions are context switching and degree of multiprogramming. Degree of multiprogramming. Degree of multiprogramming. So these definitions are also very, very important. Like during the context switch, whether the CPU is busy or not, what is exactly the degree of multiprogramming, who is controlling the degree of multiprogramming, who is reducing the degree of multiprogramming, is the context switching is value added to the system or not. So these points are very, very sensible points. Who is responsible for this context switching? These are all, and one more. See, one question I can ask you, like the smartness is required in this theory also. Like context switching, what exactly the definition for the context switching? Generally, we know that context switching means the process of saving the context of one process and loading the context of another process, right? Right, fine. Then, if I ask you a question like, in order to perform context switching, it is always required two processes. One of the MSQ statement is given like this, then what could be your answer? To perform a context switching, it is always required two processes because the definition is saying that saving the context of one process and loading the context of another process. Then the question is, in order to perform the context switching, it is always required two processes. If I pose a question to you like this, then can you tell me what exactly the statement is, whether it is true or false? Tell me. It is always required two processes. No, it is false statement. Reason, there is one special case called multitasking systems. Multitasking systems. So multitasking systems means time shared systems. In the time shared systems, the context switching can even happen. The context switching can even happen with one process. So the best example, if we consider a round robin scheduling algorithm, which is very suitable to the time shared systems. Let's say if you consider a context like a system like this, there is a process P1 and there is a process P2. Process P1 is being arrived at 0, process P2 also being arrived at 0, and the burst time of this process P2 is 9 and the burst time of this process P2 is just 3. Then if you build the Gantt chart for this, you know that with respect to this round robin scheduling algorithm, you must be aware of ready queue implementation as well as Gantt chart implementation also. Both must be well known. Now, as we stated that these two processes arrived into the ready queue in the same order, it means that first P1 is arrived, then P2 is arrived. Then in the ready queue, as P1 is the first process, so first P1 will start its execution, right? And it is going to be executed on the CPU for time 2 units, because we are considering that the time quantum for this system is 2. So every process can allow to execute on the CPU for only 2 units of time. So out of 9 units, this P1 is being executed for 2 units. Then again, it is moving to, is it with this execution, is the P1 is finished in the sense? No, it means that again, it is adding back to the ready queue like this. Then in the ready queue, what is the first process we have? P2. So now P2 is being started its execution. So this is going to be executed till 4, and with this execution is the P2 is finished in the sense? No, it means this P2 again can be added back to the ready queue like this. Then in the ready queue, the first process we are having P1. So this P1 will start its execution till 6. And with this execution is the P1 is finished in the sense? No, out of 9 units, 2 units and 2 units, total 4 units only over with respect to P1. So it means again this P1 can be added back to the ready queue. Then P2 will start its execution, it is going to be finished its execution till 7. And with this P2 is finished in the sense? Yes, because total execution time of P2 is 3, out of which 2 units is being executed here and 1 unit is being executed, total 3 units is over, so means P2 is being finished. Then I have P1 in the ready queue. So this P1 is going to be executed till 9, and with this execution, is the P1 is finished? No. And look at the smartness here. So this P1, as it is not yet finished, again it should be added back to the ready queue. Reason, you know that this is the running state and this is the ready state. This is the running state and this is ready state. There is a transition between running state to ready state. What is the transition? When there is a timeout and interrupt is occurred. When there is a timeout or interrupt is occurred, right? So timeout. So look at the time quantum is 2 units is over, means timeout is occurred. Then whichever process is currently running, that process must be added back to the ready queue. That's what we have done here. P1 is been running here from 7 to 9, as its execution is 9 units, out of 9, 2 units is over, now just 2 units is over, means 6 units is over, still it is having 3 units. So that's why again it is being adding back to the ready queue. And then this P1 again will execute, it can be executed till 11. And with this execution, is the P1 is finished in the sense? No. Again this P1 can be added back to the ready queue like this. See, look at here, if you verify this particular situation, so far P1, P2, P1 and P2, it means that context switching is going on between P1 and P2. 2 processes is required, but when you consider in this case, the context switching even occurred with one process, that is only in the special case, that is time shared system. So this sort of theory concepts are very well known by you. Okay, so these type of definitions are very important I am telling you. So those definitions are value added in solving the MSQs. If you are clear with those definitions, then it can be very value added to you while you are solving MSQ questions. Possibility is there. Mostly students used to have a confusion to solve the MSQs. The theory people generally used to ignore, but theory must be well known to you. Theory must be well known to you. So then only you are able to answer MSQ questions. So you know that the pattern of the questions is MSQs, MCQs and NATs. MSQs also having some decent weightage, right? So if you want to score MSQs, if you want to score maximum in MSQs pattern, so the compulsory, I'm suggesting you that theory is very important. So operating system is theory as well as numerical subject. You can have theory as well as you can also have numerics, right? So look at next topic, let's say scheduling criteria. So this is also must be very known, this is also must be well known topic, because here we have mentioned arrival time, we have mentioned burst time. What do you mean by arrival time? What do you mean by burst time? On what basis you are selecting one process from ready queue onto the running state? On what basis we are allowing a process to execute only certain amount of time? So like this, some what is the throughput of the system? What is the utilization of the CPU? What is the response time? What is the burst time? What is turnaround time? What is waiting time? These things are very, very important. All those things can be part of this scheduling criteria. So this is also one topic which you must know. So I can give one tick for this topic and one more tick, one tick for this particular topic. And now we are having the more ticked concept, that is process scheduling algorithms. Like you are having so many process scheduling algorithms. You are having scheduling algorithms such as FCFS, SJF non-preemptive version, SJF preemptive version, which you can call it as SRTF. Next, LJF, longest job first, non-preemptive version. Then LRTF, preemptive version of LJF. Then round robin. Then priority non-preemptive. Then priority preemptive. So priority non-preemptive, priority preemptive, priority preemptive. Multi-level queue scheduling algorithm, multi-level feedback queue scheduling algorithm. So like this, there are so many algorithms we have, around 11 algorithms we have. So those algorithms must be well known. What is the criteria? Let's say if you consider what is the criteria for FCFS? FCFS on what basis? Your scheduler, which is called your short-term scheduler, is selecting one process from the ready state onto the running state. That is depends on arrival time. So that criterias, on what basis you are executing. Let's say there is one more algorithm called HRRN. So you have previous year gate questions from FCFS, you have previous year gate question from SJF, you have so many questions from SRTF, and you have questions from LRTF, and you have also questions from round robin, so many questions. First priority among all these algorithms is SRTF, and next priority is round robin. And you have questions from priority preemptive version also. You have questions from MLQ, multi-level queue scheduling algorithm, multi-level feedback queue scheduling algorithms also. There is one smart question. Which of the following scheduling algorithms are non-preemptive? The question is like this, one of the previous year gate question. Very good question it is. Which of the following scheduling algorithms, let's say scheduling algorithms I am writing as SCA. Which of the following scheduling algorithms, scheduling algorithms is non-preemptive, let's say. Non-preemptive. What is the options you are having, you know? The options are like, the first option is FCFS, and the second option is you have round robin, and the next option is you are having multi-level queue scheduling algorithm, and the fourth option you are having multi-level feedback queue scheduling algorithm. This is one previous year gate question. So tell me which of the scheduling algorithms is non-preemptive. So non-preemptive scheduling algorithm is FCFS only. Why multi-level queue scheduling and multi-level feedback queue scheduling algorithms are not non-preemptive here? You can say that they can execute in, they are supporting both non-preemptive as well as preemptive, because your ready queue is being visualized in multiple levels, in both multi-level queue scheduling algorithm as well as multi-level feedback queue scheduling algorithm. Then in each level of ready queue, you can execute different scheduling algorithms. Like in one level of scheduling algorithm, you may execute FCFS, which is non-preemptive. In another level of scheduling, in another level of ready queue, you may execute priority scheduling algorithm, right? So it means that this multi-level queue scheduling algorithm as well as multi-level feedback queue scheduling algorithm can be executed in both preemptive as well as non-preemptive. They can support. And round robin is pure preemptive, but CFS is non-preemptive. So hence this is the answer for this question. So means I am telling you that the criteria of the scheduling algorithm is very, very important, as well as in which mode a particular scheduling algorithm is working, that is also very much important. Like FCFS is non-preemptive, SJF can work in both non-preemptive and preemptive. Preemptive SJF is also called as SRTF, sometimes it is printed as SRTN, right? So it may give in the question statement preemptive SRTN. So don't think that something is there. Preemptive SRTF in the sense SRTF by default it is preemptive. So might be the question creator is trying to trap you, by making preemptive SRTF, but actually it is preemptive only. See, if the question is not mentioned whether it is non-preemptive SJF or preemptive SJF, directly you can use non-preemptive SJF. So such criteria are very, very important. In which mode a particular algorithm is working, that is also very, very important. Those things must be very much focused with respect to the scheduling algorithms. There are several questions we have from this scheduling algorithms concept. And after this, we are having operations on a process. So this particular operations on a process, if you verify, on this particular operations on a process, you can have process. We can create. Based on process. I mean, an operating system can perform. The following two types of operations. An operating system can perform the following two operations on a process, like process creation and process termination. So what is this process creation? What is this process termination? So to terminate a process, we are using a system call called exit system call. In order to create a process, we use a system call called fork. So this is very, very important. You have very huge number of questions, like around 2 to 5 times of previous year gate questions you have from this fork system call. Like if you consider using the fork, you can create a child process, right? So when you create a process, the created process is said to be child process and creating process is said to be parent process, right? So the created process is child process, it is called child process, and the creating process is called your parent process. It is parent process. So how many processes can be, total number of processes, see the formulas these formulas must be well known. So total processes are there in the system. You know that if your program is having n number of systems, n number of fork system calls. If your program is having n number of fork system calls, then the total process in the system can be 2 to the power of n. If your program is having n number of fork system calls, then child processes can be, the number of child processes can be 2 to the power of n minus 1. So these type of formulas, based on these formulas, you have previous year gate questions, around 2 to 5 times of previous year gate questions we have. So this is very important with respect to, and specifically I am emphasizing on this particular fork. You have several previous year gate questions and use different questions on this particular fork. Like if the fork, if you include if clause statement, how the fork is behaving, If you introduce for loop, then what are the various programs you are having based on this for loop, which is including this fork system call, if clause and for loop combination, logical and logical OR. So some questions are there you can verify in our internet, and of course we have given ACE Engineering Academy materials. If you verify, several questions are there, several types of questions have been implemented in our materials based on the fork. Bits and bytes, if you verify, you can find so many questions, right? So models are there, different models you can find based on this fork system call as part of our materials. And then coming to the next topic, you have threads. So basically you are having two types of threads called kernel level threads and user level threads. So two types of threads you are having, right? So you are having two types of threads. So what are the two types of threads you have? You are having kernel level threads, in short form you can write KLT, and you are having user level threads, in short form you can write ULT. So what exactly the difference between kernel level thread and user level thread? See, based on this difference between kernel level threads and user level threads, based on the user level threads and kernel level threads differences, you have around 2 to 6 times of previous year gate questions you have. Simple, based on what is this user level thread and what is this kernel level thread. Like kernel level threads are created by the OS, user level threads are created by the user. Kernel level thread implementation is difficult, user level thread implementation is easy. User level threads context switching time is less, kernel level threads context switching time is more. So like this, so the differences if you verify, the differences you can verify, there are so many previous year gate questions based on that differences. So you need to more focus on these particular differences between kernel level threads and user level threads. So you have so many questions as per our previous papers, right? And this is also theory concept. This threads is also completely theory. And you can also have interview perspective. This threads is also very important. And with interview perspective, one more question you must be well aware, like what is the difference between a process and thread? What exactly the difference between process and thread? What exactly the difference between process and program? So these type of sensible differences must be known. So this is exactly the subtopics you can have as part of this process management part 2. Then if you verify process management part 3, here the devil comes. Who is the devil here? The devil is inter-process synchronization. This is people generally used to feel devil. So this inter-process synchronization, mostly, the questions based on inter-process synchronization is mostly with respect to 3 definitions, guys. Mutual exclusion, progress, bounded waiting. So how much grip you are having on these definitions, that much easiness you can find in solving of the questions which are based on this inter-process synchronization. So you know that this inter-process synchronization, with respect to that, if you want to understand inter-process synchronization, compulsory you must aware of, there is one topic called, one definition called critical section problem, CSP. What exactly the CSP is. And to solve this particular critical section problem, we have proposed 3 types of solutions mostly. You can say that 4 types, which is programming based, user based, hardware based, and OS based. Like, so the first one is, you can say that these are the software solutions. And next one is, you can say that hardware solutions. And the next one you can say that OS based solutions. And one more you can call it as programming language based solutions, which is called your monitors. So far we don't have, there is only one time or 2 times of previous year gate question. I hope only 1 time of question from this monitor. But if you verify the remaining software solutions, hardware solutions, and OS based solutions. See, these software solutions, you are having the solutions like lock variable, there is one solution. Decker's algorithm 1, you have one solution, which is also called as turn based algorithm. And Decker's algorithm 2, which is also called as flag based algorithm. And after that you have Peterson's solution. So such type of algorithms we have from the software solutions. You must well aware what solution is which solution is supporting or else satisfying the mutual exclusion, which solution is satisfying progress, which solution is not satisfying the bounded weighting. These things must be well known, right? And you have questions. See, while you are solving the questions based on inter-process synchronization, some smartness is required. You must be well known, brief knowledge on programming is required. Reason is, I'm going to showcase one question which is making use, which can create some trap while you are solving the question. Look at one question is there as part of our previous year papers. This is one question we have. Look at where you can find a trap here. The trap is, after this while loop, I don't have semicolon. So if I have a semicolon, the execution of this particular program is different. If I don't have a semicolon, the execution of this particular program is very different, right? So that particular thing must be well known. So while you are solving the question, you must, one or two times you need to go through the question statement properly. Some people in a hurry manner, based on the time, in a hurry manner they try to solve, then if there is a possibility of committing a mistake for not finding, if they don't find, in a hurry manner, if you don't find the semicolon or else there is no semicolon, for example, there is a semicolon, if you consider, such type of silly mistakes. If there is a semicolon, some output you can have. If there is no semicolon, some output you can have with respect to this program. Then among the options, if you verify, the options are also making you some trickiness. So this trickiness of solutions, options, if you want to chase, then you must be well aware of the definitions. That's what I'm saying. Look at here, it is mentioning mutual exclusion. It is preventing deadlock. Mutual exclusion, deadlock. See the question, the options are purely depends on two terms like mutual exclusion, deadlock. And there is one more question you can have, only mutual exclusion and progress. And there is one more question you can have, which is having based on options based on mutual exclusion, progress and bounded weighting. So I am telling you, with respect to inter-process synchronization, if you want to find, if you want to get some easiness on inter-process synchronization, compulsory you people must concentrate on the terms, the definitions like mutual exclusion, progress and bounded weighting. And along with this, you can also have hardware solutions like TSL instruction and swap instruction, what exactly this TSL is doing and what exactly the TSL or swap is doing, and which solution, which hardware solution is satisfying mutual exclusion, bounded weighting, progress. These things, those differences must be well known. And according to the hardware solutions, what is the structure of a process? According to the software solutions, what is the structure of a process? These things must be well known. And along with that, there is one more important concept which is called your OS solutions, that is your semaphores concept. Semaphores concept. The semaphores, based on the semaphores, you have most of questions from this inter-process synchronization topic. So from this inter-process synchronization topic, you can expect numericals, but these numericals cannot have 1, 2, 3 digits, right? These numericals are like the options. Earlier you have one question, you have seen one question, like option A, satisfying mutual exclusion, option B, preventing the deadlock, something. So those such type of questions you can have from this inter-process synchronization. And how many number of processes are blocked, how many number of processes are unblocked, what exactly the weight operation on the semaphore. So some questions it may mention, weight can be, sometimes it is mentioned at down. Sometimes the question based on semaphore, semaphore can be, you can access a semaphore using two types of operations. One is weight operation and signal operation. So signal, sometimes it can be used as up, sometimes it can be used as release. So those terms are also very important. Up, signal and release. These are the three operations which are incrementing your semaphore. And down or else weight, these two are the terms which are decrementing your semaphore. So those terms are very important, sensible terms. Those terms must be well known to you. And how a weight operation is being done, how a weight signal operation is being implemented, and what is the spin lock, what is the deadlock, what is the live lock. These terms are very, very important with respect to interview perspective from this inter-process synchronization. And priority inversion problem, priority inheritance protocol. So these things are very, very important where we are using this priority inheritance protocol, real-time application. So these things are very, very important. You have to focus on them. And along with that, after this inter-process synchronization, you can also have one term called inter-process communication. Like you can say that there are two types of methods basically we can use. One is shared memory and another one is shared memory and another one is message passing technique. Shared memory IPC technique, message passing IPC technique. What exactly that shared memory IPC technique and message passing IPC technique? And when you want to have a communication, compulsory you must have some link. How that link is being created, like direct method and indirect method. If a link is being created with the indirect method, what are the various properties of that particular link? And if the link is implemented with the indirect method, then what are the various properties of that link? So these things must be sensible points. Those points must be well known to you. And along with that, you are having one more concept called deadlock. So this deadlock, you can have deadlock ignorance, deadlock recovery, deadlock avoidance, deadlock detection, deadlock prevention. 5 methods. So what are the 5 methods you have from this deadlock? Deadlock prevention is there, deadlock avoidance is there, deadlock recovery is there, deadlock ignorance is there, and deadlock detection is there. So these 5 methods must be well known to you. And among that, exclusively, you have questions from deadlock prevention and you have questions from deadlock avoidance. And deadlock avoidance, you must be well known with respect to single instance per resource and multiple instances per resource. If it is a single instance per resource, then in order to avoid the deadlock, we are using resource allocation graph algorithm. If the resource is having multiple instances, then in order to avoid the deadlock, we are using banker's safety algorithm. If the resource is having single instance, then in order to detect the deadlock, we are using wait for graph. If the resource is having multiple instances, then in order to detect the deadlock, we are using an algorithm called resource request algorithm. So like this, there are some sort of things. If a resource is having multiple instances, if the resource is having a single instance, some important points like resource allocation graph contains cycle, then what will happen? Surely it is a deadlock? No. So resource allocation graph contains cycle, then what is the situation? Deadlock may or may not occur. So it means that is the cycle is necessary condition or else is the cycle is necessary and sufficient condition? You must be aware of these terms. What is the necessary condition? What is necessary and sufficient condition? Right? So there are some relations like if the progress is violated, then deadlock is occurred. But for all progress violations, deadlock occurred. So some relations like if the deadlock is occurred, then progress is violated. If the deadlock is occurred, then progress gets violated. But for all progress, deadlock may or may not occur. So these type of keywords, these type of keynote points must be well known to you. Right? What is the difference between starvation? What is the difference between deadlock? What is the difference between starvation, deadlock, and convoy effect? You must be able to define all these things. These are all very, very important for the interview perspective. Right? And along with that, you can also have concurrency. So in this concurrency, what we can focus mostly, we can focus on par begin and par end. There is one concept. Based on these questions, based on this concurrency, you have questions in previous year papers such as 1992, 1995. During that period, we have questions from this par begin par end, which is also can be called as co-begin co-end, concurrent begin, concurrent end, par begin, parallel begin and parallel end. Along with that, you can also find one more concurrency programming construct which is called fork join construct. And in order to say that two statements can be executed in parallel, then we are having some concurrency conditions called Bernstein conditions. What are those Bernstein conditions? These things must be focused on this concurrency as part of this concurrency part. So these are the very important topics with respect to your process management part 3, and mostly you have to focus on this inter-process synchronization here. After this, I can say for this 4 ticks, and after that you can have deadlock. For this I can give 3 ticks. So these are the 2 topics which you must be focused on this process management part 3. So after that you have the next main topic we have is memory management. So this memory management also having lot of stuff. So that stuff for simplification purpose, we have divided that stuff into 3 parts like memory management part 1, part 2 and part 3. So look at what are the contents we can have as part of this memory management part 1. If you verify what is the capacity of memory, you have one previous year gate question from this. And what is the RAM chip implementation? How you can implement a RAM? And what are the classification of memory management techniques like contiguous memory management techniques and non-contiguous memory management technique, and that too fixed partition techniques and variable partition techniques, right? So that contiguous is being divided into fixed partition and variable partition, correct? No? So this is being divided into 2 parts. One is contiguous memory management techniques and another one is non-contiguous memory management techniques. And again, this contiguous memory management technique is being 2 types. One is fixed partition technique and another one is variable partition technique, which you can also call it as static and dynamic. And if you know this fixed partition technique and variable partition technique, you can easily able to understand what is this partition allocation techniques. So partition allocation techniques, what are the techniques we have? First fit, best fit, worst fit and next fit. These things can be seen as part of this, and we have several questions, and the questions are very smart questions. One of the question I can say, so from this memory management you have one question from memory capacity calculation in previous papers, and you have one question from RAM chip implementation, and you have one question from, there are several questions from this partition allocation technique. So from this particular topic, I can strongly suggest you to focus on this partition allocation technique. What is exactly first fit is doing, what exactly the best fit is doing, what exactly the worst fit is doing, what exactly the next fit is doing. So here, if you verify one of the question like this, so this question is being given in our previous papers. Look at, so here some processes requests have been given, and which of the following partition allocation technique is satisfying that? Look at either best fit or first fit but not best fit but not first fit, none of the above. So it means that am I going to use fixed partition technique or else am I going to use variable partition technique? So if you want to know, you must be well known of the question statement. You must have a brief idea of the question statement. So based on one term here, you can easily able to answer this question. Like the question, the keyword of this question is heap. So what is the meaning of that heap? Heap is a dynamic memory, means variable memory. So when it is variable memory, in a partition, you are having 150 partition and 350 partition, you can able to, if it is fixed partition technique, you are allowing only one process into one partition. But in variable partition technique, while smaller process requests are keep on arriving, a larger partition can be further partitioned. So it means that in a partition, you can have more and more number of processes. Then you must be very much emphasized with respect to interview point of perspective, you must be well known of what is internal fragmentation, what is external fragmentation. The fragmentations must be well known to you. Internal fragmentation, external fragmentation, these things must be well known to you. Right? And these are the things which you can see as part of this memory management part 1. Then if you look at the memory management part 2, where you can see non-contiguous memory management techniques. These are all non-contiguous memory management techniques. Non-contiguous memory management techniques. Very, very important techniques. You have several times of previous year gate questions from this paging concept and multi-level paging, and that too, this paging you can see in 3 versions. What are the 3 versions? Like one is you can say that simple paging, and another one is you can see that paging with the TLB, paging with TLB, and another one you can say that paging with TLB and physically addressed cache, which is PAC. Same, if you look into the multi-level paging, which is also called as hierarchical paging. So this multi-level paging also you can visualize into 3 parts, like normal multi-level paging, simple multi-level paging you can say, and then multi-level paging with TLB, and then multi-level paging with TLB and physically addressed cache. You have questions from this. See here, it might be given like this. I mean, might be, you can say that in this particular paging with the TLB and PAC, you can say that there are 2 types of caches. TLB is one cache and physically addressed cache memory is also one cache. 2 caches you are using. TLB is the cache of page table and cache memory is the cache of your physical memory. So then if your the questions can be like this, like if your caches are not in line, then what is the effective memory access time? If the caches are in line, what is the effective memory access time? See, concept is very important. It is not by hearting the formulas. If the caches are in line, the formula is going to be for effective memory access time is different. And the caches are not in line, then the formula for effective memory access time is different. So when you are clarity about the concept, when you are having the clarity about the concept, then only you are able to answer the questions. By hearting a formula is not much suggestible thing to you. Understand the concept, then automatically the formula you can able to easily understand the formula. Right? So these things can be, you can see 3 versions of paging here. You can see 3 versions of multi-level paging here. And then you are having inverted paging and then segmentation. After that segmented paging. And you are having one more concept I forgot to mention here, which is your memory protection. There is one more concept called memory protection. So as part of this memory protection, you can see what exactly the base register is doing and limit register is doing. If you know this limit register and base register functions, then you can easily able to understand what exactly the segmentation is and what exactly this segmented paging. If you want to understand the segmented paging, you must be well known of this paging and segmentation. And you have already one previous year gate question based on this segmented paging. So these things must be well known to you, right? After this memory management part 2, you can have memory management part 3, where you can see virtual memory concepts. What exactly virtual memory is? This virtual memory can be implemented in using both demand segmentation and demand paging. So if you want to know what is demand paging, compulsory demand, if you want to know what exactly the demand paging is, you must be well aware of paging concept. If you want to know demand segmentation, compulsory you must be well aware of segmentation. Then you must be able to distinguish what is demand paging and what is demand segmentation. And which is been mostly used among these 2 techniques, which is been used mostly to implement this virtual memory concept. What is the reason? So these points are very, very important, to learn. You must be focused on all these points. And after that you have page replacement algorithms. Like you can see the page replacement algorithms like FIFO page replacement algorithm, optimal page replacement algorithm, LRU page replacement algorithm, MRU page replacement algorithm, LFU page replacement algorithm, MFU page replacement algorithm, second chance, like LRU approximation algorithms you are having. LRU approximation algorithms called reference bit algorithm, and after that you can see that additional reference bit algorithm, and after that you can see that second chance algorithm, and so like this there are 4 approximations you are having. So all those algorithms must be well known to you. LFU, MFU, LRU, MRU, optimal, FIFO, and reference bit algorithm, additional reference bit algorithm, second chance algorithm, and NRU. You can say that this is last one is enhanced second chance algorithm. You can call it as enhanced second chance algorithm. So these things must be well known. And after that, what exactly the thrashing is? Is the thrashing is value added to the system? Is the thrashing is not value added to the system? How you can control the thrashing? How you can recover your system from thrashing? How you can prevent the thrashing? Controlling in the sense prevention, avoidance, and how you are recovering your system from thrashing if it is occurred. So these things must be well known to you, and this is one of the important concept called working set model. You have one previous year gate question also from this. How you are controlling the thrashing, and along with this, you can implement the demand paging, and you can implement this virtual memory using these 2 techniques, but we prefer this demand paging fine. But to implement this virtual memory, you need some requirements. So what are the requirements to implement your virtual memory? The requirements are, you can say that there are 2 requirements you have. What are the 2 requirements? One is page replacement algorithms, and another one is frame allocation techniques. Like equal allocation technique, equal frame allocation technique, and proportional frame allocation technique. So these things well known to you. Page replacement algorithms anyway you are covering, but this is the hidden concept. Equal allocation and frame allocation techniques, equal allocation frame allocation technique, and proportional frame allocation technique. These things must be well known to you. So these are the important things. Here from this memory management part 3, the most focus is on this particular page replacement algorithms. After this you can concentrate on this working set model. So from this memory management part 2, the most important content is paging, and after that you can have multi-level paging, and after that you can have segmentation. And if you verify your memory management part 1, as I mentioned that the most focus is on partition allocation techniques. So after looking at this memory management, then we can see your file systems. So file management or else file systems. So in this file management or else in this file systems, you can have the most important content is like file allocation techniques like indexed allocation technique, file allocation techniques like indexed allocation technique, contiguous file allocation technique, linked allocation technique, and indexed allocation technique. And in this file management also, you can suffer from internal fragmentation and external fragmentation. What is exactly this internal fragmentation in the file systems? What exactly the external fragmentation in the file systems? What exactly internal fragmentation in the memory management? What exactly the external fragmentation in the memory management? You must be able to distinguish that. And after this topic, the next important topic is file indexed allocation. I mean this inode implementation. Most of the questions, numerical questions from this inode implementation, very important content it is. This is most important topic here. And after this, you are having free space management. There is one more topic called free space management, like bitmap, linked allocation, grouping, and counting. Very important, free space management. When a file is being deleted, then some memory space is going to be free. Then that memory space collection can be done in 3 ways, like free space management. That is called your free space management. And after this, you can also have one more important content called disk scheduling algorithms. What are the disk scheduling algorithms you have? The disk scheduling algorithms like FCFS, after FCFS, then SSTF, scan, C-scan, look, C-look, okay, FCFS, SSTF, scans, C-scan, look, C-look. These algorithms are very, very important. So this is also one of the most important topic from this file management. So, and along with this, you are having some additional techniques, some additional topics that are comes under, like file inits concept. This is one topic you can have, and you can also have file access methods like random access, sequential access, right? And along with that, you can also have one more topic called directory structures, file directory structures. So like this, some optional topics are there as part of this file management. Optional in the sense, comparatively these topics, these are not much important to focus, but these are the topics which you have to focus on your preparation, as part of your preparation. So this is what entirely your operating system preparation strategy. So which topics are very, very important, on which topics you must be focused, and what type of precautions you have to take up while you are solving the questions. So these things, if you want to know, when you are well aware of these things, then only you are able to answer the questions effectively. Right? I hope this session is very helpful to all of you, and please pass this particular, share this particular information to all our friends, so that they let them get benefited with this session, how you can prepare for operating system subject for GATE examination. Right? So along with this, in our next session, we are going to see some important concepts of this particular operating system. I can choose, as I mentioned, SRTF, round robin are very important. So what I can do, one example based on SRTF, one example based on round robin in our next session, which is going to be conducted on tomorrow. So similarly, semaphores, we can see what exactly the semaphore is, what are the various differences between binary and counting, and what type of numericals we can have on semaphores. Those things can be covered on tomorrow. Like one example based on multi-level paging, one example based on simple paging, one example based on this segmented paging, one example based on page replacement algorithms, one example based on. So one example we can cover on tomorrow from each and every important topic of these main topics of this operating system. Right? So I hope the session is very helpful to all of you. Thank you.